So let's talk about infrastructure, specifically cloud infrastructure. If you've been building in the cloud for a while, it's probably not a concept that's new to you. You likely deal with things like virtual machines, databases, networking configurations, security controls, and you probably manage this through infrastructure as code. But what if you could use natural language to help manage this? In the past, there really wasn't a good answer to this, but today that changes. Let's talk about the AWS Cloud Control API MCP Server. Let's start by recapping what infrastructure as code is. It's the management of infrastructure through code instead of through manual processes. So instead of going through a management console and clicking through a wizard to create the infrastructure that you need, you're creating it via code, and the code is representing the infrastructure that you want to create. Now, there are a number of different tools that you can use for infrastructure as code, things like AWS CloudFormation, AWS CDK or Cloud Development Kit, Terraform, Pulumi. There's a number of options that are out there, and you might be using one or have experience with multiple of them. Regardless of what tool you use, there are some common benefits that they provide. Things like repeatability, peer review, version control, being able to store the state of your infrastructure at one point in time and roll back if you need to. All these tools are great and they solve a ton of challenges and they're widely adopted in the industry. You might be thinking, is there something I can do to streamline this even further and help scale myself and my team out even more? And that really brings us to what's on the bleeding edge, AI-driven infrastructure management. Now, hold on. I know what you might be thinking, but let me cook a little bit. So when you're dealing with infrastructure as code, you might run into a couple of challenges along the way. You might have experience with one infrastructure as code tool or maybe multiple of them, but let's take a scenario. Assume you're at a maybe mid to large size company and there's that goal of using one infrastructure as code tool. And you could think for a number of obvious reasons, right? The standardization, easier to enforce governance, it's easier to maintain your existing CI/CD pipelines and keep those optimized and not have to, have the sprawl of multiple infrastructure as code tools. And that's what a lot of companies want to get to. Now, as much as companies want to standardize on a single infrastructure as code tool, a lot of them haven't gotten there yet. They might be using a combination of these tools, which can cause some challenges, but organically, it's not that uncommon for this to happen. Sometimes multiple tools are used to avoid being a bottleneck for innovation. Now, yes, ultimately, you do likely want to standardize to a single infrastructure as code tool for production, but what about for lower level environments like development or sandbox accounts? Sometimes being too strict can really slow things down, or more importantly, it might not even be time for infrastructure as code yet. So let's talk through a scenario that you might be familiar with. Imagine you're a data scientist and you need some infrastructure spun up in the cloud platform that your company uses. Maybe there's some new feature that you want to work on or some optimization that you want to try for a pipeline, something that you want to validate. Now, what that process might entail is you creating a ticket, that ticket then being added to a backlog that a DevOps engineer has to cycle through. They have to then investigate the ticket, maybe reach out to you if they need more clarifying information, and then ultimately create the infrastructure. The challenge is that this process can really add friction on both sides of it, right? Now the DevOps engineer has an increasing amount of tickets that they have to go through to create this infrastructure, and the data scientist now has a gap from the time that they need to or desire to create that new feature or that new optimization, and to the point that they're able to actually have something spun up in the account so they can validate their assumptions. And even further, what if their assumptions are wrong and now they need different infrastructure spun up or changes to the infrastructure that was created? Now the cycle can kind of rinse and repeat. But what if the data scientist could simply use natural language to ask for the infrastructure that they need and validate their assumptions and more rapidly work on that feature or that new enhancement? Then, once they're done and they've validated those assumptions, they could ask for the infrastructure as code to be generated. That way they can hand that off to a DevOps engineer who would actually do the implementation and production via likely some existing CI/CD pipelines. In the past, there wasn't really a good solution to this other than the ticket-based system, right? Or something similar. But today I want to talk about another potential solution, the AWS Cloud Control API MCP Server. Now, if you haven't heard of the AWS Cloud Control API, It's a unified API to make it easier to interact with AWS services. You might have familiarity with using AWS Service APIs and the different syntax that can happen across the different services. Say, for example, with EC2 and S3. EC2 describe instances, or AWS S3 LS. Effectively, you're doing the same thing. You're saying list all of my EC2 instances or list all of my S3 buckets, but it's a completely different syntax, right? The AWS CCAPI helps standardize this by allowing for CRUDL operations, so create, read, update, delete, and list, to be ran against AWS services. And this is really the core of the AWS CCAPI MCP server. Now, that's enough about the theory. Let's hop into a demo and see it in action. All right, so let's go ahead and start by getting the MCP server installed and configured. All these links are going to be in the description below, but we'll start by going to the AWS MCP server's doc site, and we're going to go into the available AWS MCP servers, infrastructure and deployment, and then the Cloud Control API MCP server. And then you can go down, use these quick links on the side to get down to installation. You can click add to cursor or install in VS Code, and then there's some information about the MCP configuration file. So this might be different depending on if you're using the Q developer CLI or the IDE extension or cursor or Klein or any of those ones. But there's going to be a similar configuration file where you define the MCP servers. And you can see an example here. You source it from AWS Labs CCAPI MCP server, and we're going to grab the latest. There's an AWS profile that we can pass in, default tags, security scanning. There's also more information on the different options. So in authentication, you could also use environment variables. And then profile could either be standard AWS profile or AWS single sign-on is also supported. So feel free to read through the docs if you want some more information about that. But for now, we're just going to use a standard AWS profile. Also inside the GitHub repo, inside of source, CCAPI MCP server. You can also see the README here if you want to use that. So either option to see the instructions you have at your disposal. Also, if you kind of want to poke around and see how the MCP server is configured a bit more, you can go inside of the AWS Labs CCAPI MCP server, and then this is all the code here. Specifically, you can also see the server.py is going to be that core file that you need. But let's go ahead and hop into VS Code. And you can see I already have this configured, so same configuration as you saw on the other page, but I'm using one of my specific AWS profiles. I have my default tags enabled, security scanning enabled, and that looks good to me. So I'm going to run QChat to start a new QChat session. I'm going to be using Amazon Q Developer, the Q CLI specifically for this. And it can take some time to load for the first time. In my testing, it's been anywhere from like 15 to 20 seconds just from the initial load, but then it should cache it and it should be faster from subsequent runs. If you run / /MCP, it gives you a status of it. So you can see now it's loaded. If we do / tools, we can see a list of the built-in tools for the Q CLI, and then also for the MCP server. There's only one MCP server, so because there's only one in the configuration. So that looks good to me. Now let's actually try to create some infrastructure. So let's say create an S3 bucket with a new KMS key. So we want to try to create something that has dependent resources. So we'll let that think. And the first thing that it's going to do is use the MCP server check environment variables tool. So what that's doing is basically checking these environment variables because these configure how the MCP server should work, right? Do you want security scanning enabled or disabled? Default tags enabled or disabled? What AWS profile or environment variables would you want to use? So it's always going to start with that. I'm going to do Y to accept that. There's three options: yes, no, or trust. Yes or no is going to prompt you every time the tool is attempted to be ran. It's going to ask you to basically give that validation. T for trust is not going to ask you anymore for the duration of the current session. So I found that the next thing it's going to do is get the AWS session info. So basically using the profile, validating that there's valid AWS credentials, and then it's going to output the session information. So you can see here that it's giving me like the account ID, region, profile, and it's a standard AWS profile and not single sign-on. The next thing it's going to do is generate infrastructure code. So all this is really doing is creating the representation of the infrastructure that we want to create, right? So in this case, the KMS key that's going to be used for bucket encryption for S3. Now it seems similar to probably a JSON structure for a CloudFormation template. All this is really being used for is to generate, to run security scanning against this code. Then for the actual call to create the infrastructure with the Cloud Control API, it's going to be using the required fields from this structure. So if it seems similar to CloudFormation, don't get confused. It's not deploying a CloudFormation stack. It's creating this effectively template. That way we can validate security scanning, then use the fields that we need to actually create the infrastructure with CCAPI. So I'm going to do yes. I recommend for create and update operations to just do yes or no. That way you always get the second layer of validation before it actually attempts to create something. The next thing it's going to do is to explain. So explain what that infrastructure would represent. So I'm going to do yes. Explain, you could also trust if you wanted to, since that's not really a potentially changing operation. It's just going to be explaining what's going to happen. So there's some information. You can see a description, some properties, the policy, what it actually does, and then this is important, these default tags. So since the default tags is enabled, it's going to be adding these by default. So CCAPI MCP Server, the source code pointing to the Git repo, and then the version. The next thing it's going to do is to run use checkoff. So use this tool to do the security scanning. And this one takes a little bit more time, so we'll give this a little bit, but effectively it's going to be taking that template, running checkoff against it, and seeing if there's any security findings, and then letting us know about those findings, and then how we want to proceed. So if finished doing that, the next thing it's going to do is it's going to explain. So explain the security findings. So I'm going to do yes to accept that. And then similar as before, it's explaining the security findings. So there was one pass, one failed check. Is telling us about the key rotation is not enabled, so that's why it failed to check. And then the one that did pass is fine. And then it gives us, it pauses and asks us how we want to proceed. Do we want to fix the issue? Do we want to proceed anyway, or do we want to cancel? I'm going to just say keep going, because that's something that's not a blocker for what I'm trying to do for the sake of this demo. Okay, so now that the security scanning passed, is actually going to go ahead and call the create resource tool to try to create that actual infrastructure. So I'm going to do yes. Okay, and now what it's going to do is use the get resource request status tool to basically use the request token and validate with the CCAPI, has that infrastructure been created or modified, has that operation finished yet? So I'm going to do yes. And now it's validated that the key was created. It gives you that key ID. The next thing that it's going to do is the same thing as before, generate infrastructure code, but now for the S3 bucket, right? And if you see, it's actually using the KMS key here, right? So the same KMS key that was created, it's now being used for the S3 bucket. So I'm going to do Y for yes. And as before, it should, get the session info. So second video will explain this more, but it's basically ensuring that we have fresh tokens because, AWS credentials can expire. So you want to make sure that it wants to make sure that it still has valid credentials before it tries to create it. So now it's going to try to regenerate the infrastructure code. Again, still using that same KMS key. Now it's going to explain. So explain what's actually going to be created with that infrastructure. And then you can see here, it's S3 bucket, talks about some of the properties. You also see those same default tags because, again, I have default tags enabled. And since I have security scanning enabled, right, it's going to, again, run checkoff for this piece of the infrastructure. All right, and then you sees that there's 2 failed checks, but it's going to go ahead and proceed with the creation because earlier I said keep going when there was a security, issue. Now, if you wanted to, you could say actually, hey, what was the security finding? And you can kind of chat and dive into that a little bit further. So let's actually try that. So what what were the 2 failed checks? And let's see what it gives us. All right, and then it lets us know what those 2 are, and then it's basically saying, do you want us to fix it or proceed? So it looks like access logging and versioning. I don't really care about that for the sake of this demo, so I'm going to say, now let's keep going. All right, cool. So now it's going to, again, try to do create resource. And then finally do that get resource request status again. So validating, has the S3 bucket been created? It's going to check again. It's probably still in the process of creation. And now we get the success message. So it successfully created both those resources, the KMS key and the S3 bucket. Now let's check some of the security guardrails that are built into the MCP server. You might be thinking, well, can I use this to do potentially destructive things? And there are some good guardrails that are in place for that. So let's try to do something like delete literally everything in my AWS account. And let's see what it says. And it says, I cannot and will not delete everything in your AWS account. Would be extremely destructive. And then it kind of helps you. Do you want a more targeted cleanup approach instead? So there's guardrails like that that are going to be, in place. And then you could also say things like maybe, can you help me update my S3 bucket? I want literally anyone in the world to be able to access it. Let's see what that does. All right, and now it says it's not going to help you make it publicly accessible to the world, but then it also says that if you have a legitimate use case, I can help you with alternatives and things like that. So again, there's some good guardrails in place to help enforce some of those, prevent those insecure operations to happen. So let's go ahead and say, okay, let's delete just what you created. All right, so now it's going to delete the KMS key and the S3 bucket. So first it's going to explain what it's going to do. So again, you could use this, say if you want to delete something that already existed for some reason, it will explain to you what's going to actually happen. So then it's going to call the actual delete resource tool. Then what it's going to do is actually get the AWS session info. So to ensure that the API operation doesn't fail due to credentials that expired, it's going to check that again and make sure those are fresh. Then it's going to go ahead and do the delete resource. Then it's going to get the request status. And I'm actually going to trust this because, again, that's just more of like a read operation. So now it's going to delete the KMS key. So I'm going to explain it. I'm going to just trust this because, again, for the sake of this demo, I'm fine at this point. So it's explaining the deletion. Then it's going to proceed with the delete resource that I'm going to trust. Get AWS session info again, because now for the S3 bucket, it probably wants to, again, make sure there's valid credentials. I'm going to trust that again. And delete resource. So you see, since that I did trust, it didn't ask me again, do I want to continue? Same thing with get request resource request status. So it'll just kind of continue on at this point since I authorized it to keep doing so. It's going to keep checking to see if the deletion is in progress. And now we have deletion complete. So with natural language, we have successfully created a KMS key and an S3 bucket and used that KMS key to encrypt the S3 bucket. And then we've deleted those resources, and then we have also validated that there are some guardrails in place to prevent some massively, destructive operations from happening. So there also is a flag that if you look in the documentation, you can tack on a -- read only, and that way you can use the MCP server to maybe just do some read operations. One thing that also you might want to do is say, can you help me check if my existing S3 buckets are secure? Right. So beyond just creating and updating, say if you want to just use it for ad hoc security scanning. So what it's going to do is use the list resources tool. And it's going to constrain it, right? It doesn't want to say if you have thousands of S3 buckets, right? It's going to, by default, set this max resources to analyze to be 5 of them. So we're going to let that run and see the next thing that it's going to try to do. All right, and now it's giving a summary of them. 11 buckets in my account. 5 were analyzed with security scanning. So basically on the back end, it was using Chekhov. And then it basically is giving us some, better security. One has versioning enabled. You can see some other stuff that's in there. One failed, etc. Excellent coverage, but could benefit from versioning. And I'm going to say, okay, thanks. That is all. And then let's just validate. So have you cleaned up everything you created? Yep, and then it gives you the validation again that it has. So with that being said, that concludes the demo. We've successfully created the S3 bucket. We have in the KMS key, we've deleted both, and then we've used the MCP server for ad hoc, just checking the security of some of the resources that are in the AWS account. So that about does it for today's video. Hopefully you got a good overview of the CCAPI MCP server and some of what's possible, but again, that's really just scratching the surface of what's possible here. I invite you to try out the CCAPI MCP server and let me know what you think. I had a ton of fun working on this. I learned so much in the process, and I'm happy to chat about my findings. And if you're interested to learn a little bit more about how it works under the hood, don't be shy. Click the next video. If you found this video helpful, like, comment, and share with others you think also might like it. And subscribe to see more content like this. That's all for now. I'll catch you in the next one. Peace.